My name is Aishwarya, so welcome to NEETMET. So today, I'll be teaching you one of the most confusing chapter, which is thermodynamics. Thermodynamics involves a lot of formulas and we have no clear idea when to insert those formulas. And also we have a lot of confusion regarding graphs, how to plot the graph, how to understand the graph and how to understand the question, because we don't have the conceptual link, because we are just sitting and memorizing the formula, which is not actually good. Okay, so because the questions are getting difficult, so we need to have a understanding of how things work, then only you'll be able to come to a conclusion, right? So that's why today we will be doing the basics of thermodynamics, as well as we'll do the work done under the PV graph. Okay, so let's start with what is thermodynamics. Thermodynamics is the branch of science that deals with the heat or energy transfer, how energy behaves, transforms, and how it affects the surroundings. Okay, so this chapter involves only three things, which is heat, energy, and work. That's it. That's the main point of this whole thing. Involves only three things: energy, heat, and work. That's it. How it behaves, how it affects the surroundings. That's it. Let's start with thermodynamical system. Okay, I'm taking a container. Okay, I'm taking a pistol. I'm going to put pressure now. Okay, this gas molecules is the system. System is where we are going to put our focus or observe how energy or heat behaves. That's the system. And container, piston, or the room and all are known as surroundings. So the container or the room or anything other than the system is known as the surroundings. So the system and surroundings is collectively known as universe. Universe comprises of system and surrounding. System is where we are going to put our focus to study the energy transfer. Surrounding is other than the system, let it be room or the container, anything other than the system. And system plus surroundings gives universe. Okay. Next, let's start with types of system. Types of system. First is the open system. Second is closed system. Third is isolated system. Okay. Open system is where there is transfer of both energy and mass. For example, you're boiling water in an open vessel. That is an example of open system, because there is transfer of both energy and mass. Second is closed system, where there is only transfer of energy but no transfer of mass. For example, gas in a sealed cylinder. There is only exchange of energy, no exchange of mass. Third is the isolated, where there is no transfer of both energy and mass. For example, you can say a thermos flask. Why? Because it's perfectly insulated, so there is no transfer of both energy and mass. So these are the three types of system. Okay. Okay, see, we learnt about system, okay? But how we know the state of condition? So we have come to the state variables. State variables is the one which tells us the state. They are very important because there's no point in only having systems and types of system. We need to know the condition. So there are three: temperature, pressure, and volume. Next is the properties of system. Properties of system are divided into two types: intensive and extensive. Intensive are independent of mass. Extensive is dependent on mass. See, intensive, going to change according to that. But if I'm going to double and half or change the size of the quantity, what happens is that it will remain the same. That is intensive. For example, pressure, and you can say density and temperature are all intensive. Extensive, you can say it as internal energy, enthalpy, volume, and entropy. Okay, so intensive are independent of mass, extensive are dependent on mass. So these are the properties of a system. One tells us the condition, the other tells us the size of the system. So the first question is, which one of the following is intensive properties in a thermodynamic system? First option, pressure. Second is enthalpy. Third is internal energy. Fourth is the entropy. We know in the properties of system we learned intensive and extensive, right? Intensive is independent of mass and extensive is dependent on mass, right? Dependent on mass. So it is given pressure, enthalpy, internal energy, entropy. We know enthalpy is extensive. Entropy is extensive. And internal energy is also extensive. So the only option left is pressure. Pressure is intensive. Okay, so the option is first option, A option is the right answer. Okay guys, let's go to the second question. A frictionless piston cylinder based enclosure contains some amount of gas at pressure of 400. Then heat is transferred to gas at constant pressure in quasi-static process. The piston moves up slowly through height of 10 centimeter. Piston has cross-section area of 0.3 meter square. The work done in the process. So first, in this type of question, you have to write the data first. Let's convert into meter. Okay, so 10 to the power minus 3 Pascal. Okay, next. Height is given as 10 centimeter. We have to convert into meter, which is 10 into 10 to the power minus 2 meter. Okay, next height is given area. Area is 0.3 meter square. Next is, okay, so that's all given. You have to find the work done in the process. So 4 options are given. Okay, let's write the formula. Work done equals to pressure into change in volume. We know change in volume equals to area into dx, if you remember. So pressure is given 400 into 10 to the power minus 3 into area 0.3 and dx you can write it as height. Okay, volume will be area into height. Okay, into 10 to the power minus 2. So the answer you will get is 12. Okay, now the options are given in kilojoule. So how do you convert into kilojoule? Divided by 1000. Answer will be 12 kilojoule. 12 kilojoule is the option A. So that's how you solve this question. Celsius and normal pressure requires 52 calories of heat energy to convert steam at 0 degrees Celsius. If volume of steam produced is 167.1 cubic centimeter, the change in internal energy. So let's write the data first. Mass equals to 0.1 gram, let it remain. Temperature equals to Celsius, T equals to 1. Next, the heat is given 54 calories. Volume is 167.1 cubic centimeter. Let's convert it into cubic meter. Because 1 meter equals to 10 to the power minus 2 meters. So cubic centimeter is 10 to the power minus 3. Okay, that's how we convert. Next, they're asking you what is delta U. What is the internal energy they are asking? First of all, 1 calorie. The options are given in joules, so you have to convert calorie to joules. 1 calorie equals to 4.1 joules. Sometimes this part will be given in the question itself. If it's not given, you can use this value. So Q equals to 54 into 4.18 is 225.72 joules. Okay. Next, they're saying water at 100 degrees Celsius converts into steam at 100 degrees Celsius. Temperature is remaining, the temperature is same, okay? Just the phase is changing. Now we know this formula, Q equals to delta U plus delta W, right? So we know this formula. Now what you have to do, you have to substitute. Delta W is P into change in volume. We know pressure is given into 10 to the power 5 into change in volume. Volume is 167.1 into 10 to the power minus 6. So the answer which I was getting is, okay, delta V is Vf minus final minus initial. What is the final? We are given mass as 0.1 gram. So density equals to mass by volume. Volume is 0.1 into density. Into density is 1. So we are getting 0.1. Okay. So what do you have to do? Minus. The initial one is 0.1. So 167.1 minus 1 into 1 point. This answer you might get it as. Okay. So this will be the delta W. And we know delta Q, we are getting it as 225 minus 72 joules. So delta U equals to delta Q minus W. So 225.72 minus. So the answer you are getting it as 209 joules. So directly this answer is not given, but the nearby answer is 208.7 joules. This answer. So the option will be the B option. See, even if you're not getting the direct answer, you just see what is nearby, because the answer depends on this part. Okay. However, it can be 4.2, it can be 4.18. It depends on the question. If it's given in the question, directly come and substitute, or else just get an approximate answer. Okay. Okay, let's go to the fourth question. 500 gram of water is heated from 30 degrees Celsius to 60 degrees Celsius, ignoring slight expansion of water. Calculate the change in internal energy of water. Specific heat is given. Okay. Let's write the data given. Mass is 500 grams converted into 0.5 kg. Delta T is 60 minus 30, which is 30 degrees Celsius. Next, they are asking you to find delta U. They say the slight expansion is negligible. That means delta V is not considered. Okay, not considered. Remember one thing: if delta V is 0, the work done will also be 0. This comes under isochloric process. Let's do that in next video. But remember, delta V is negligible or 0. Delta W is also work done as 0. Next, you have to find out delta U. Now, Q equals to U plus, this is cancelled because answer is 0. U equals to delta Q, and let's use this formula M, specific heat into temperature. You have to know this formula, delta Q equals to M into specific heat into delta T. Specific heat that's given in the question, 1484. So let's just substitute 0.5 into 4184 into 30. So the answer you might get is 62760. Okay, this is coming in joule, right? Convert into kilojoule. 2 decimal places, so 62176 kg. This is second option, B option. So this is how you do the questions. Okay. So I guess you would have understood how to use this formula. And for delta Q, see, for delta Q, there can be two formulas, okay, also. ML and MS. This is latent heat, this is specific heat, okay. If there is only phase change, if the ice is melting, if it is boiling, that is actually phase change. In that scenario, you have to use this formula. Mass into latent heat. Latent heat will be given or not given, okay. So this is ml. Next, if there is temperature change, like from 0 to 50 degrees heated, or from 70 to 140, or like that, if there is a temperature change, you have to use mass into specific heat into temperature. So these things you have to have it in mind, okay. So you can substitute it as ml equals to U plus W, or ms root T equals to U plus W. So this question came in May 2018 somewhere. They gave a phase change, like ice is melted, like same like the previous question. So that's how you use, instead of Q, you have to put M into L, which is mass into latent heat. Latent heat will be given in the question itself. So guys, that's the usage of the first law of thermodynamics. So in next video, let's do some graphs, as well as let's do the types of processes and Carnot engine, and let's do all the PYQs, okay, related. So thank you.